Hi guys, happy Valentine's Day, and I hope that you received beautiful gifts from your partners, and those who are single, I hope that they find their partners and celebrate Valentine's Day next year with them. So we have a question from related rates of change, saying two automobiles are approaching an intersection on a straight roads that intersect at right angle. Car A is traveling at 40 mile per hour and car B at 50 mile per hour. When car A is 3 miles from the intersection, car B is 4 miles. At that instant, find the rate at which the distance is changing between the cars. And happy Valentine again. The answer would be is to graph the right angle. So this is the path of car B and this is the path of car Y. Let's call this side Y and this side X, and the distance between the two cars Z. So we said we're given dx over dt equals minus 50 meters per hour. And why it's minus? Because the distance is decreasing as car B is approaching the intersection. And same here, y dy over dt equals negative 40 mile per hour because it's decreasing also. Y equals 3 miles at that instant and X equals 4 miles at that instant, which means car A is 3 miles away from the intersection and car B is 4 miles at that instant from the intersection. Okay, so we're given those informations and he wants the dz over dt, which is the rate that the distance between the two cars change. First of all, we should find z. So we have a right triangle, so we can apply the Pythagorean theorem. So z squared equal x squared plus y squared, z squared equal 4 squared plus 3 squared equals 25. So z equal 5 miles. We cannot say it's equal to minus 5 because this is a distance. Z is a distance. Alright? But velocity is a vector, so we can say it's minus when it's decreasing and positive when it's increasing. Now we apply the Pythagorean theorem again to make our equation, and this time we take the derivatives of every variable with respect to time. Remember, related rates of change, we derive every variable with respect to time. We have z squared equal x squared plus y squared again. Then when we derive 2z dz over dt equal 2x dx over dt plus 2y dy over dt. Now we start to plug in our values. So this is our equation again. 2z equal 5. We found that z equal 5. dz over dt equals 2. X is 4 minus 50, which is dx over dt, plus 2. Y is given 3. dy over dt is given minus 40. So we have little algebra now. to clear everything. 10 dz over dt equal negative 400 negative plus negative 240. dz over dt equals to negative 640 over 10, which equals to minus 64 mile per hour. That means that this distance here is decreasing between the cars, the distance between the cars as they approach the intersection. This distance between them is decreasing at a rate minus 64 miles per hour. I'll let you take a final look about the answer and to digest the ideas and how we solved it. Finally, you have some sense of humor. This is the Valentine's heart, which has two partners, X and Y, who are all people in relationships who celebrated the Valentine's Day.